Hi everyone, welcome to our physics class. In the previous class, we have completed alternating current. In this class, I am going to discuss about the next a very important, very simple chapter, that is electromagnetic waves. The total duration of this chapter is 2 hours and it is possible to ask 2 mark. Okay, well, so let's start today's class. The first concept in this chapter, that is inconsistency in Ampere's circuital law and its modification made by Maxwell. So inconsistency means sometimes Ampere's circuital law is applicable, but sometimes it is not applicable. Okay, sometimes it is correct, sometimes it is not correct for some kind of situations. So actually, that is called the inconsistency. Inconsistency in Ampere's circuital law and its modification made by Maxwell. According to Ampere's circuital law, what is the statement of Ampere's circuital law? It's a very simple statement, right? According to Ampere's circuital law, the line integral of magnetic field around any closed circuit, that is equal to mu naught times the net current passing through the closed curve or closed circuit. So this is actually the statement of the Ampere's circuital law. The line integral of magnetic field around any closed circuit, that is exactly equal to mu naught times the net current passing through the closed circuit, or the magnetic field B vector is directed along the tangent to each and every point in the perimeter L of a closed curve, and its magnitude is constant along the curve. That is actually the simplified statement of Ampere's circuital law. Okay, so to understand the inconsistency of Ampere's circuital law, let us consider the process of charging of a capacitor. Okay, to understand this inconsistency, that is an Ampere's circuital law. Okay, just consider the process of charging a capacitor. What is the meaning of capacitor? Capacitor is a device used for storing electric charge, right? So this is actually a part of electrical circuit. So this is the capacitor, right? So this is actually Amperian loop. Okay. So let us consider S1. Let's consider this one as S1. S1 with a plane circular surface of radius, that is R. S1 plane circular surface radius. So the radius of this plane circular surface, that is R. R is the radius of this plane circular surface of radius R, whose center lies on the wire. Center lies on the wire carrying current, and its plane is perpendicular to the direction of current in the wire. Okay, according to Ampere's circuital law, the line integral of magnetic field around any closed circuit is equal to mu naught times the net current passing through the closed circuit. So, to understand the inconsistency of Ampere's circuital law, first let us consider the process of charging of a capacitor. Okay, so let S1 be the plane circular surface of radius r center lies on the wire carrying current, and its plane is perpendicular. The plane of the surface that is perpendicular to the direction of current in the wire. Okay, the plane of the surface, circular surface that is perpendicular to the direction of current in the wire. So now let us consider an observation point here. So at that point, we have to calculate the magnetic field that is due to the current in the wire. Okay. So to determine magnetic field, to determine the magnetic field at P, to determine the magnetic field at P. So let us apply Ampere's circuital law to the surface S1. Actually, we have the line integral of magnetic field around any closed circuit that is equal to mu naught times the net current passing through the closed circuit. Okay. So according to right hand thumb rule, so what is the direction of magnetic field in this loop? That is very important, right? What is the direction of magnetic field in this circular loop? That is actually, that is in that is in anti-clockwise, right? The straight current carrying conductor is held in the right hand, the thumb pointing in the direction of current, the fingers encircle, which gives the direction of magnetic field. Thumb pointing in the direction of current, fingers encircle, which gives the direction of magnetic field. So according to right hand thumb rule, the direction of magnetic field in this loop that is in anti-clockwise direction. Okay, and what is the direction of dl vector? Actually, dl vector at each and every point on this loop that is tangential. Even magnetic field is also tangential. So how do you find out the direction of magnetic field at any point on the loop? So by taking a tangent at that point, right? So the direction of magnetic field at each and every point on the loop that is tangential, and dl vector. So dl is the small length of the loop. Okay, so dl vector is tangential to the circular path. B vector is also tangential to the circular path. So what is the angle in between B vector and dl vector? So that is very important. So here, what is the direction of magnetic field at each and every point on the perimeter? That is tangential. What is the direction of dl vector at each and every point of the loop? So that is also tangential. So what is the angle between B vector and dl vector? That is 0. So the integration of dot product of two actors, that is given by the product of magnitude of two actors and the cosine of the angle in between them. So here cos 0 is 1, right? Cos 0, so that is equal to mu naught I. So B is the magnitude of magnetic field. So the magnitude of magnetic field at each and every point on the perimeter L of a closed curve, that is always constant. Okay, magnitude of magnetic field at any point on the loop, that is constant because those points are equidistant from the center. Okay, so that is why B is just take it as outside. B integration of dl cos 0 is 1, so that is equal to mu naught I. So B integration of dl is L, that is equal to mu naught I. So L is the total length of the loop. So total length of the loop, that is 2 pi r, right? Or is a radius. So total length of the loop is 2 pi r, that is equal to mu naught I. So the magnetic field at this point P, that is exactly equal to mu naught I divided by 2 pi r. So this is the magnetic field at the point P. Now let us consider again the process of charging of a capacitor. But here, so this is a pot shaped surface. Let's consider that is S2. So S2 be a pot shaped surface without lid. Okay, so S2B a pot shaped. This is a pot shaped surface without lid, and its bottom between the plates which does not touch the current. So what is this? Actually, this is a plain circular surface. So actually here current passing through this the plain circular surface. But here what is the current passing through this pot shaped surface? Actually conduction through it is zero. No current passing through this surface. Okay, because the current carrying wire does not touch the surface. What is the meaning of S2? S2 be a pot shaped surface without lid, and its bottom between the plates which does not touch the current. Since the surface does not touch the current carrying wire, so conduction through it is zero. There is no current flowing through the surface S2. Actually here the current flowing through the plane surface, but here current flowing through this surface S2. Okay, that is actually zero. So when we apply when we apply Ampere's circuital law, when we apply Ampere's circuital law to S2, so we have integration of B vector dot dl vector, that is equal to 0. So according to Ampere's circuital law, the line integral of magnetic field around any closed surface, that is equal to mu naught times the net current passing through this surface. Right? Now what is the magnetic field at the same point P? That is equal to 0, right? So calculated one way, there is a magnetic field at point P. Calculated another way, there is no magnetic field at the same point. So this clearly shows that there is some inconsistency in Ampere's circular law. Is it not? So here actually we will get the magnetic field, that is mu naught I divided by 2 pi r. But in this case, there is no magnetic field. So this clearly shows that there is some inconsistency in Ampere's circular law. If the circuit includes a capacitor, okay, when circuit includes a capacitor, so actually Ampere's circular law is not consistent. Okay, so modification was made by Maxwell. Modification was made by Maxwell in Ampere's circular law in order to remove inconsistency. Actually, in order to remove the inconsistency, Maxwell suggested the existence of an additional current. So this point is very, very important to remove the inconsistency of Ampere's circular law. So Maxwell suggested an existence of an additional current. Actually, that current is called the displacement current. Okay, to remove the inconsistency of Ampere's circular law, so Maxwell suggested that an existence, the existence of an additional current. Okay, actually that current is called the displacement current. So displacement current means actually the current produces that is due to the time varying electric field. Now look at this circuit, part of circuit carefully. Actually here in between the plates there is a uniform electric field. In between the plates there is electric field. Electric field always start from positive charge and terminate on the negative charge. So there is a uniform electric field between the plates. Okay, so here actually the time varying electric field produces current that is actually called the displacement current. So what is the meaning of displacement current? Current produces due to time varying electric field. Okay, current produces due to the time varying electric field. Current produces due to time varying electric field is called displacement current. Okay, so conduction current, actually here there is a conduction current, but here there is a displacement current. Conduction current produces due to the flow of charges. Displacement current produces due to the time varying electric field. Okay, conduction current produces due to the flow of charges. So what is the mathematical expression for conduction current? The differences between the conduction current and displacement current. So that is very important. Conduction current and the displacement current. Conduction current and displacement current. According to Ohm's law, V is equal to IR. So the conduction current mathematical expression is IC is equal to V by R. So the mathematical expression for displacement current, ID is equal to epsilon naught into d phi E divided by dt. ID is equal to epsilon naught into d phi E divided by dt. So this is actually the mathematical expression for displacement current. So what is the meaning of conduction current? Conduction current means current produces due to the flow of charges. So what is the meaning of displacement current? Displacement current means current produces, that is due to the time varying electric field. So let us derive this mathematical expression, that is ID is equal to epsilon naught d phi E divided by dt. Okay, so this mathematical expression, so that can be derived by using, so the process of charging a capacitor. Consider the process of charging a capacitor. And electric field exists between the plates. So what about the electric field outside the plates? Actually outside there is no electric field. So in between the plates there is a uniform electric field. So the magnitude of electric field between the plates, the magnitude of electric field between the magnitude of electric field between the plates is E is equal to V divided by D. So V is the potential difference between the plates, D is the separation between the plates, E is the electric field between the plates. So E is equal to V divided by D. So when charge is given to one of the plate, what happens to its potential difference? The potential difference between the plates that will rises. That means Q is directly proportional to V. Q is equal to CV. So V is Q by C. So what is the value of V? V is Q by C. So what is the meaning of C? That is actually the capacity of parallel plate capacitor. Okay, so what is the mathematical expression for capacity of parallel plate capacitor? Capacity of parallel plate capacitor is C is equal to epsilon naught A by D. Is it not? This is the mathematical expression for capacity of parallel plate air capacitor. Okay, so C value, that is epsilon naught A divided by D into D. So D get cancels. So Q is equal to epsilon naught E A. Okay, so actually here the electric flux through this surface, electric flux. What is the meaning of electric flux? Electric flux means the number of electric field lines passing normal to the given surface. So electric flux is measured by taking the dot product of electric field vector and area vector. So actually this is the direction of E vector. Even A vector is also along the same direction. So E vector, A vector is parallel here. So this is normal and this is the direction of electric field, right? So actually this is normal, right? This is normal. And this is the direction of electric field. So both are parallel. What is the angle in between them? 0. So E vector dot A vector, that is EA cos 0. This is EA cos 0. Cos 0 is 1. So the electric flux is EA, right? So EA is phi E. So Q is equal to epsilon naught into phi E. Okay. So the displacement current ID, current is the rate of flow of charge. So ID is equal to dq by dt. So d divided by dt of what is the value of q? Q is epsilon naught into phi e. Okay, so epsilon naught is constant, take it as outside. So epsilon naught into d phi e divided by dt. Okay, so this is actually the mathematical expression for the displacement current. What is the meaning of displacement current? Current produces due to the time varying electric field. Conduction current means current produces due to the flow of charges. So displacement current means current produces due to the time varying electric field. Okay, so finally, Ampere's circuital law is restated as Ampere's circuital law is restated as integration of B vector dot dl vector. The line integral of magnetic field around any closed circuit, that is equal to mu naught times the sum of conduction current and displacement current. Okay, actually this is called Ampere-Maxwell law. So what is this? It is actually Ampere-Maxwell law. This is Ampere Ampere Maxwell law. So what is the statement of Ampere Maxwell law? The line integral of magnetic field. The line integral of magnetic field around any closed circuit or closed surface. So that is equal to mu naught times the sum of the conduction current and the displacement current. So that means integration of B vector dot dl vector, that is equal to mu naught of IC plus ID is epsilon naught d phi e divided by dt. Okay, so this is the mathematical expression. What is this? Mathematical expression. Mathematical expression for Ampere-Maxwell's law. And this is actually the derivation of the displacement current. This is the derivation of the displacement current. So displacement current means the current produces due to the time varying electric field. So in order to remove the inconsistency, Maxwell suggested the existence of an additional current. Okay, so that is actually called displacement current. So this is the modified Ampere's law. So modification was made by Maxwell, right? So this is about inconsistency in Ampere's circular law and its modification made by Maxwell, right? So calculated one way, there is a magnetic field at point P. Calculated another way, so there is no magnetic field. Means so there is some inconsistency in Ampere's circular law that is removed by Maxwell. Okay. Okay. Thank you.